My name is Evandro. I had been working CHUVA campaign, basically more related to the instrumentation with lighting sensors and more close. My work is more near the electrostatic field mills observation during the campaign. And I had been working during the installation process, the sensor and data validation, and I hope show for you how is the process of data validation, the field mill, what the status this data validation, and what values the field mill observed in all field campaigns during the CHUVA that have measures of the electrostatic field mills. So, all measurements realized by three kinds of sensor: a Campbell sensor, Voltec, and a field mill non-commercial development in university. This field mill non-commercial, I believe that the first calibration process that I realized, I remember that this first process I realized in 2008 when Cesar Benetti received me in CIMEPAR to realize the first analyze this prototypical field mill with another Campbell sensor, the CIMEPAR. And this process started before the CHUVA campaign. When we started the CHUVA campaign, we already had some calibrations and curves for correct measures, this field mills and this field mills too. But now I realized new curves and recalibration all data in the last month. I finished the level 2 data this process. But always we do this process before the CHUVA campaign starts. This process have been always realized. Okay, the sensors. This is a Campbell sensor. This is a Voltec sensor. There's different kinds of sensors. This field mill realized measures for the mill, and this is another procedure that open and close a plate, and this is a prototypical field mill. We have some pictures, data acquisition. This is during the Vale do Paraíba in Pequenópolis school, this sensor. And my question during this campaign is more important is this: how I can ensure the different sensors have the same measures. How can I say this? Okay, for the Campbell sensor, this sensor have a factory calibration, but another sensor not have a factory calibration, and I don't know what the values correspond in volt per meter. Okay, and the process, and I basically I have to install all sensors that goes to campaigns together in the same point in the ground, and wait the thunderstorm overpasses for analyzing and comparing this data. It's important we have the fast variation in electric field for you study the performance, the different sensor in this responsible for have the fast variation in the time the electric field for realize a good comparison. Okay, and this is two thunderstorms that I select when all sensors was installed at USP. This case, someone must be remembered that this is a 14 February 14, the huge thunderstorm in São Paulo. We have a fast flooding at USP, and all sensors was installed, and the process calibration is very good. This is a huge thunderstorm to comparing all the sensors. And the data was recalibrated with these new curves. For example, this is a electric field corrected. The voltages in these thunderstorms in the order than 10,000 volts per meter. This is a volts per meter. Don't have the unity. Okay, and this is a two thunderstorm. One more positive thunderstorm for evaluate the positive values, and another one together more negative for study all variations. Okay, for example, what's the result of this comparison? For example, this is a Campbell, Missouri. This Missouri, I believe that is correct, and these values correspond in the volt per meter. And this is values of the field mill Boltec. For example, we have different values and have to compare this value with the calibrated sensor. Okay, this is a dispersion plot. The comparison, the two sensors. It's interesting to note this is a similar linear curve, but it's not linear. We have some perturbations. And this is data after the corrections. For example, the blue line corresponding the Campbell sensor, and the white is the Missouri, the Boltec sensor after the corrections curve. And the corresponding is very good corresponding after the corrections. And first we have Missouri, the Boltec field mills between 10 volts, but after the correct, the Missouri corresponding the another sensor. For example, the sensor development in university, the responsible is not so linear, but after the correction, non-linear correction, the electric field is good. Okay, and basically the last curve obtained is very good because I evaluate the high voltage. And another ones, I don't have a so huge thunderstorm to compare. And I believe that the new curves is more realistic. Okay, the status of field mill reprocessing after that obtain curves for each sensors. This is all sensors that participate in the CHUVA campaign, Belém, Vale do Paraíba, and Santa Maria that have the field mill Missouri. The level 1, basically the raw data, have some errors, time errors, and not have the calibration curves application. The level 1, we have the corrections, the time, and the correction, the curves, the electric field, but the level 2 is the new curves applied. All day. Okay? Now, and after the reprocessing all data, I went to show a result that showed all the Missouri's realized in the field campaigns. So for this, I select only the moments of thunderstorm because I don't want to study the fair weather, for example. And then I select only the lightning position. For example, I can take the field mill curves and realize a derivative, the electric field in the time, and I can find the fast electric field variation and select lightning positions and study only the electric fields 1 minute before the lightning occurrence. This is a form that I study only electric fields inside the thunderstorm. Okay, if I study these paths inside each field mill in all experiments, and analyze this with a density probability function done with a histogram with besides the 10 volt per meter, we can see the more frequency of occurrence than electric field for the 3 sites. And we can see an interesting result that Belém have more negative electric field associated with the lighting process. Okay? And Santa Maria and Valley is more similar. So, if I cut the portion, negative portion, the thunderstorms observed, and the positive part and studied separately, I can see the cumulative distribution of frequency for the negative portion. We can see the values. The values is more high in Belém than another ones, okay, for negative portion. This is an interesting result. Why this happened in Belém? This is just a different electrification process in Belém, because it's very different than another one. Okay, in ICCP Morales, in first investigation, the radar vertical profiles point that the ecotops in Belém is more highest. Okay, if Belém have the main strong signature, the electric field negative, what's happening in this thunderstorm? For example, this model, if I consider this model, okay, and inside the conductor, the ground conductor, we have the charge induced in the conductor in accordance with this distribution. If I put this in a simple model, we can see with the field mu we observe it, considering the simple model. Okay, we have this position. I have more influence this charge center and induce the negative electric field above the thunderstorm. For example, that I believe that Belém, this charge center that induces a negative charge inside the ground is more strong than another sites, Valley and Santa Maria. Okay? For example, if you need to study the charge center in thunderstorm, we have, for example, if you use the inverse problem, the Coulomb inverse problem present for Moacir, for example, you have to put a field mu here for study this charge center, and electric field mu here for study this influence, because the different position we can study the different charge positions. Okay. So, and this conclusion, the basically conclusion is the level 2 is finished the process, and Belém indicate the charge center positive above the base code, the code base more charged, the Valley and Santa Maria. This is more conclusions. Okay, it's this, and I invite you for access these websites, and you can see some quick looks the thunderstorm and electric field measures. Okay, it's this.
Questions? No one?
That's an interesting comment about the lower positive charge. Just a comment that I don't know if this helps, but in comparing New Mexico thunderstorms and Florida thunderstorms, I would say that the manifestation of the lower positive charge is more dramatic in New Mexico than it is in Florida. But that sort of runs opposite to what you have, that Belém would be more tropical, like Florida. And so I'm not sure what that means, but anyway, for what it's worth.
So I'm considering the ecotop more highest in Belém, and the discharge center more intense. They favorite the process the close to ground lighting. If we have the discharge center more robust, we have more facility the charge close to ground have. But in Belém, we don't have so much close to ground charge. We observed and analyzed the last results, the StarNet network, for example, and Valley and Santa Maria have so much close to ground. And the ecotop more highest, I believe that this sandwich, this charge is more highest. And in Belém. And you have so much influence this charge center, but not have so much cultural ground. We have to investigate more this. But I believe that the Belém, we have so more intercloud lighting in this charge center development and no cultural ground lighting.
Okay, thank you, Evandro.